So we are on page 2 of the note packet, and today we'll be starting the second learning target on rational exponents. So what's nice about this is we are going to be going kind of back to some of our math spam rules, but we're also going to be tying it to some of the things we've been doing with square roots. So the question that I got asked yesterday at some point was, how can I type in the cube root of 27 on my calculator? We can look up 27 and see that it's a perfect cube on our cube sheet, but currently we have no way of checking ourselves on our calculator. This is where rational exponents come into play, and they're also going to help us with some more complicated problems that would involve multiplying radicals that have different indices. So we're going to go ahead and just look at our word up at the top, rational exponents. Rational is kind of synonymous with fractional. So rational exponents look like this. We're going to be doing two things in this section. We're going to be rewriting expressions, and then we are going to be simplifying expressions. Keeping these two things straight will be important so that you don't kind of do more work than you need to on problems that are just rewriting. So if I tell you that 27 to the 1/3 power is the same as the cube root of 27, we can actually see this equality by using what we have done to simplify our variable and exponent powers. To take a variable out of the square root, we took the power divided by the index. We can actually do the same thing with numbers. So the current power of the 27 would be a 1, and power divided by the index of 3 gives me 27 to the 1/3. So taking something to the 1/3 power is the same as taking the cube root of it. So x to the power divided by index is equal to x to the power and the index, or the index of x raised to a power. So that's something that's kind of interesting about this is I can actually have that power of p inside the radical or outside the radical and get the exact same answer. So the other thing that I want you to write by these two forms is that the first one is exponential form, because we have an exponent associated with it, and this form is radical form. Because it has the radical symbol with it. So in this first section, we're kind of going to be just going back and forth between these two ways. And if you're like, why would we get fractions involved when the radicals are a perfectly legit way of writing these expressions? We'll get to kind of the why and the utility of the fractional exponents at the bottom of this page. So for right now, just bear with me, and we're going to see how these forms are equal to each other. So if I have the negative square root of 16, the power of that 16 would be 1, and the index of that radical would be 2. So 16 divided by index gives me 16 to the 1/2, and the negative remains out. So the top number is your power, and the bottom number is your index, or what root you are taking. Now, this is where I want you to get out your calculators. If I told you to take the cube root of 8 without using your purple sheet or yellow sheet or whatever color it is, we could put this in on our calculator as 8 to the 1 divided by 3 power. So on my calculator, if I do 8 caret button 1 divided by 3, what is the cube root of 8? 2. Now, the chunky calculators, you're going to have one additional step with this. So if you've got one of the non-LED calculators, you are going to have to enclose that 1 divided by 3 in parentheses. So I want everybody to try typing this in on your calculator. So older, chunkier calculators use parentheses around the 1 divided by 3. Calculators like this one, you can just do caret button to the 1 divided by 3 power. And we get 2, and sometimes that's a little disarming because it's like, wait, isn't it like 8/3? We are not multiplying 8 by 1/3. We are raising it to a 1/3 power. So just like squaring is related to square rooting, taking something to a fractional power is related to rooting as well. So make sure that you know how to type this in on your calculator, and this can be how we check what cube roots, 4th roots, and 5th roots are. So if I wanted to take the 4th root of something, what power would I raise it to? If I wanted to take the 4th root of 16, what power would we raise it to? The 1 divided by 4 power, the 1/4 power. So 4th root, 1/4. 5th root, 1/5. 6th root, 1/6. Now looking at this one, I've got 27 to the 2/3 power, so that means the index of my radical, or the root, is a cube root, and the power of the 27 is 2. And as I mentioned over here, you can associate that squared on the outside or on the inside. So taking the cube root of 27 squared is the same as taking the cube root of 27, is the same as taking 27 squared and then the cube root of it. So that's kind of interesting that we can do the root first and then the power, or we can do the power and then the root. So something to keep in mind as we start simplifying. So on this one, we've got -16 to the 3/2 power. The 2 is the index of the radical, and the 3 is the power. So here's my radical. Does that have an index of 2? Sure does. Anytime we have just a regular square root, the index is 2. Yes, I will. Okay, perfect. Thank you. Bye-bye. Because you're supposed to go down to student services, and they said you're leaving for the day, so we'll finish your test on Monday. I won't share anything on here. All right, folks. So in this first section, I want you to put a box around this, around these example 1. Oops, just drew on my cart. I want you on this section to write rewriting, not simplifying. And I want to bring this explicitly to your attention because on the previous page, when we were trying to simplify something like this, did we want to get a z to the 7/3 power? No, fractions are no good when we are trying to simplify. We want to try to get as many even items out of the radical as possible. It starts in radical form. We keep it in radical form when we are simplifying. But if I'm trying to rewrite it using fractional exponents, the fractions are going to be okay. So for example, on problem A, if this is radical form, and I want to write it in exponential form, I would take the power divided by the index and get x to the 3/4 power. It's gross, but we're not trying to simplify here. We are just rewriting it in terms of those nasty exponents. So then what would the power of z be? The power of a single z is 1, so then power divided by the index of the radical, we get z to the 1/4, which says, hey, we're taking the 4th root of z. And then power divided by the index for the y, power of 2 divided by the index of 4, we get y to the 2/4. Why am I not going to leave my answer like that for that y? What should we do with that fraction? Simplify it. So I'm not simplifying the radical itself, but if I encounter a fraction that can be simplified, absolutely reduce it. And there we are. We now have an expression in exponential form. Now, what about b? If I take power divided by index, we get c to the negative 5/3. Going back to Unit 5, what do you guys remember about those negative powers or those bad attitudes? Are we going to leave it with a bad attitude? Send it to the downstairs to take care of that bad attitude or resolve that negative. So we're going to send it to the downstairs, and we get 1 over c to the 5/3. So I'm just rewriting it, but handling any power issues like non-reduced fractions or negative exponents. So now we're going to go in the other direction. We are starting with exponential form, and we are going to try to write it in radical form. So x to the 1/6 means the power is 1 and the index is 6. So I'm going to put that x underneath a radical with an index of 6 and a power of 1. Or I can just write the 6th root of x. So you don't have to have that power of 1 there. Taking something to the 1/6 power is the same as taking the 6th root of it. Same with this one. I've got x to the 7/4. Now, a strategy that you can use is the denominator is always going to be your index. So I could twist this apart and make this x to the 1/4 raised to the 7th. Is this the same as what I started with? When I am powering up, what am I going to do with those exponents? We would multiply them. So is 1/4 times 7 the same as 7/4? It is. So if you wanted to, you could twist apart the power into kind of the denominator, which tells you the root. The 1/4 power will be the 4th root, and then the power of 7. So you can draw a little cloud around that. So the 4th root of x to the 7th, that would be one way of writing your answer. Or you could do the 4th root of x raised to the 7th. So those two are the same, and I would accept either on a test. The index is 4, the power is 7. Any questions so far? And again, right now it's like, all right, we have this other form, but what is the whole point of it? Folks, I want you to take those calculators and put them in your bag or under your, or on the floor somewhere. In this next section, we are going to be evaluating these without a calculator. Which, if I were you, I'd be like, no way, absolutely not. So in this section, no calculator. You must show radical work on test and on the homework. So no calculator. You must show the radical work on the test. You can still use that power sheet. Does anybody need a new power sheet? I have smaller ones printed off now. Those little white sheets that are note card sized over there, so I have nice small ones now that you can use. You will be allowed to do that, but this section would be no calculator. We are going to use our calculator to check ourselves but we're going to see how we can do this nasty negative fractional power, which I know we don't really love fractions, and we are going to do it all without our calculator. So folks, down in the section below, I want you to write mad spam. That was way back from Unit 5. This stands for what we are doing with the bases, multiplying, dividing, or powering up. And then the exponents tells us what we are doing with the exponents, adding, subtracting, or multiplying. So I'm going to be using powering up to kind of twist apart that power like I did in this problem. So I am going to try to change this into the root part, which will make the radical, the power part, and then the negative part, if applicable. So my root power here would be the 1/4. So I'm going to split this to be 81 to the 1/4 power. That is the root power. Then I don't have like an additional power, like I don't have a 3 in the numerator for power divided by index, so the power is just 1, and it doesn't really matter. Now, do I have a negative power? Yes. So we would raise this to the negative 1. Is this the same as what we started with? Yes, because if I power up 81 to the 1/4 and raise it to the negative first power, I would multiply those and I would still get negative 1/4. So I don't move anything. I'm just twisting apart the power and changing the way that it looks to break it down into the power parts. So 81 to the 1/4 is the same as taking what root of 81? The 4th root of 81. So this is where I would want to go to my perfect sheet and say, what is the 4th root of 81? It is 3. So the 4th root of 81 is 3. My last step is to evaluate that negative exponent. How do I take 3 to the negative 1 and send it to the downstairs? What would we get? 1/3. Wow, and we did it without our calculator. Now, if I were you, after I showed the required work, so I would write required work. I would probably check myself on the calculator. So 81 raised to the negative 1 divided by 4. And we get 0.3 repeating. Math, enter, enter. Boom. And that gives us 1/3. So older calculators, don't forget to put parentheses around your fractional exponents, but we can check ourselves after we have shown all of that lovely work. Let's go ahead and try problem B. So here we have 216 raised to the 2/3 power. First, we are going to break it down into the root power. Which part of this power gives me the root? Kind of the denominator part of it. So we're going to have 216 to the 1/3 power. That's going to give me that cube root. What power am I going to have on the outside? Squared. So is this the same as 216 to the 2/3 if I multiply those fractions? Yep, sure is. Haven't changed the value. So what I can do from here is take the cube root of 216 and using our purple sheet, yellow sheet, whichever color you have, the cube root of 216 would be 6. So the cube root of 216 is 6. And then our final step would be to square it. So 6 squared is 36. And we did it without our calculator. Now there are other ways we could break up the power. So I want you to write or, if this pen will work, or what if instead of 216 to the 1/3, I did 216 squared raised to the 1/3? Does this give me the same thing I started with? If I power up, don't we still get 216 to the 2/3? Yeah. So why wouldn't I want to do it this way? What's 216 squared? Well, I definitely have to use my calculator for that, so that's a problem. So let's see, that would be 46,656. And then taking that to the 1/3 power means I need to take the cube root of it. I look on my sheet for a perfect cube that is that big. Do we have one? Nope. So doing it without my calculator is very not friendly. But if I did want to use it on my calculator, we could take 46,656 to the 1/3 power, and we would see that we get the same answer of 36. So I did have to use my calculator. This number was huge, which I didn't like, so that's why this is not our best method. That's why, folks, for our steps, I recommend breaking it into the root power, using the denominator first, then the actual power, the numerator on the top, and then the negative power. We are going to go into the guided practice, the blue sheet. And we're going to do number 2. It's plugged in there. You can just take it to your desk. It's on the other side. So we're going to look at number 2. 81 to the negative 3/4 power. So what would you say is the root power here? The dividing by 4 part. So I'm going to split apart the power and say 81 to the 1/4. Then my other power, 3. And then the negative power, -1. Now I'm powering up, so if I multiplied all of those, would I still get 81 to the negative 3/4? We would. So we're just breaking it down into the root aspect first, because that's going to give me the smallest number. Then we're going to take that small number and cube it, and then we're going to send it to the downstairs and make it a fraction. So let's start with 81 to the 1/4. That's going to be the 4th root of 81. Cubed. -1. Looking on our list of cubes, our perfect fours, what is the 4th root of 81? There's 81. The 4th root would be 3, because 3 times 3 is 9, times another 3 is 27, times another 3 is 81. So the cube root of 81 gives me 3. What is 3 to the 3rd? 3 times 3 is 9 times 3 is 27. And then 27 to the negative 1. We give that 27 a bad attitude and send it to the downstairs. We get 1 over 27. And there's our final answer. And if I wanted to check it on my calculator, 81 to the negative 3/4. Math, enter, enter. Ta-da! We get 127. So folks, on your own, I want you to try number 1. Showing the step of breaking the power, evaluating the radical root, and simplifying. What did you use for the root power? The 1/3. What did you use for the other power? We're raising it to the second. And again, could we flip those powers around and say 216 squared and then to the 1/3 power? Yeah, but we don't want to get that giant number we'd get when we square 216. So taking the root first is the way to go. So the cube root of 216. What is the cube root of 216? It is 6, looking at our yellow sheet. And then squared is 36. That was the same one that was in your notes. Did you catch that? Just getting some extra practice there. All right, folks, so here is what we are going to do. In your purple homework packet, I want you to cross off number 23 and 27. Don't do them, ever. And in this first block of problems, you are just rewriting. So if it's in exponential form, like number 22, write it in radical form. And if it's in radical form, write it in exponential form. So here you are just rewriting. And then you can also do through number 32. Those ones you are doing without a calculator, but you must show the conversion to a radical first. If you just write the answer, you're not going to get credit on the test. That's like an automatic 0 if you just show that for that section. So you do have to be able to show the appropriate work for those. So let's go ahead and go through, let's do 28, maybe 29 as well. So on 28, we only have the root power. So the only thing I need to show is that 343 to the 1/3 is the same as taking the cube root of 343, which, looking on your yellow sheet, would be equal to 7. Now, what about number 29? What is our root power? The 1/5 power. And then the other power that we are breaking it into is the -1. So 32 to the 1/5 is the same as taking the 5th root of 32. Looking on your perfect sheet, the 5th root of 32 would be 2. And then what's 2 to the negative 1? Take that 2, send it to the downstairs. We get 1 over 2, or 1/2. So folks, I'm going to give you some time to work on 20 through 32, this section, before we move on to the next portion of the notes.